Starting from where I left off in the previous video, I was discussing about this velocity distribution. So maximum velocity can be given by this equation 1 by 4 mu into dp by dx into r square, and also it can be shown that average velocity is given by u max by 2, and discharge through the circular pipe is given by, as I told you earlier, while calculating discharge we make use of average velocity. So Q is equal to A into U average. So A is pi r square for a pipe and U average is U max by 2. Earlier I was talking about the energy loss due to friction in pipe. So the head loss due to friction in pipe of length L is given by the Darcy-Weisbach equation, that is HL is equal to FLV square by 2GD. Here F is called the friction factor, that is Darcy-Weisbach friction factor, and L is the length of the pipe, and V is the average velocity of the flow, G is acceleration due to gravity, D is the diameter of the pipe. Here Darcy-Weisbach friction factor F value for laminar flow can be given by 64 by Re. So substituting F as 64 by Re in the above equation, and also making use of Re equal to rho Vd by mu, and making the adjustments, we will get 32 mu Vl by rho G d square as the head loss due to friction. Now since we are interested in knowing the power required to run the pump, so we should know the extra power needed to overcome the frictional resistance. So power required to overcome the frictional resistance in a pipe of length L and diameter D is given by P is equal to rho G QH. So we know this equation, basic equation. Here the head should be replaced by the head loss due to friction HL. And there are some other terms which we are interested to know here, like coed flow. It is the laminar flow of viscous fluid in the space between two parallel plates, one of which is moving relative to the other. So coed flow is basically the laminar flow between the plates, wherein one plate will be moving with respect to the other. And creeping flow is the, as the name suggests itself, creeping is the very slow motion of the fluid. So in this case, in this type of flow, the inertial forces are negligible compared to the viscous forces. So whenever there is a Reynolds number is less than 1, we call it as creeping flow. Coming on to the external flow, that is flow over a flat plate. In this case, the Reynolds number can be given by the equation x into u infinity by nu. Nu is kinematic viscosity. U infinity is the free stream velocity, that is the velocity with which the fluid is approaching the plate before coming in contact with the plate. X is the distance from the leading edge, where we are interested to know the Reynolds number. So this is the leading edge. So if we are interested to know the Reynolds number at this point, so this is the distance x, we should substitute here. For flow over flat plate, the condition for laminar and turbulent flow is Reynolds number. If it is less than 5 into 10 raised to 5, then it is laminar, otherwise it is turbulent. So in this diagram we are seeing laminar boundary layer and turbulent boundary layer and all. This will be discussed in the boundary layer theory, that's why I have not touched upon this. So this is it from the laminar and turbulent flow basics. And also I have not discussed how these equations are derived, since these are not of much importance. The derivation is not of much importance for GATE exam. So only thing is we need to remember these equations and use it when given in question for solving the problems. That's it. Thank you.